What we're going to do is try to solve for x for this problem. The absolute value of 2x plus 1 is equal to 7. Now you might be tempted to start just adding or subtracting 1 from both sides and dividing by 2, but you can't do that. There's some rules you have to follow. So one of the first rules is let's isolate what's inside the absolute value, or 2x plus 1. Well, we already did it. It's by itself. That's what isolate means. So we've done that. The second thing we're going to do is, well, our journey is to solve for x. Okay, that's what we want to do. In order to do that, what we have to realize is what's inside this absolute value could equal a positive 7, or it could equal a negative 7. So what I like to do is the little branch. I like to say, well, 2x plus 1, that's what's inside the absolute value, could equal 7, or 2x plus 1 could equal negative, and we'll indicate that with red, a negative 7. All we need to do now, since we don't have the absolute value sign, is we need to solve for x in both cases. So we get 2x is going to equal 6 on that side. We're going to divide both sides by 2, and we get x equals 3. So in one case, we have x equals 3. You might be tempted to write, well, if x equals 3, then it can also equal negative 3, but you can't do that. You actually have to do the math part of it and solve the other side, or the negative side, of this absolute value problem. So we're going to subtract 1 from both sides. We'll get 2x is equal to negative 8. And when we divide, we'll get x is equal to negative 4. So our solutions are x equals 3 and x equals negative 4. And we did the problem. So here's another problem. It says solve for x. We're just doing absolute value problems at this point. So if the absolute value of 2x plus 5 is equal to x minus 2, how do we solve this for x? Well, let's break it up. I always like to isolate what's inside the absolute value. I always like to isolate 2x plus 5 and that absolute value. So you want to isolate the absolute value is basically what I'm trying to say. Whatever's inside, that's what you have to keep on one side of the equation. It's already done for us. We don't really have to do that. And the second thing is we have to solve for x. And the way we're going to do that is we're going to take whatever's inside the absolute value. Remember, it's like we're pulling off, we're stripping that 2x plus 5 absolute value. We're just taking the signs off, or the absolute value sign off, and we're going to make it equal to the positive version, or the regular version, of what's on the right side of the equation. But even though we're doing that, we're actually going to be looking at the negative side as well. So this is the positive side, and this is the negative side. So let's go ahead and write 2x plus 5 is equal to, and what we have to do is write that negative sign, and it's going to be the negative of whatever is on the right-hand side. So that's where our best friend, the parentheses, comes from. Okay, we need to use that in this case. So let's go back over to the left-hand side. Let's go ahead and solve this for x. We're going to have two x's, one x and another x. That's what we're going for here. All right, so let's subtract 5 from both sides. We get 2x is equal to x minus 7. Because at this point now, we're trying to solve for x. We're trying to isolate x, right? So I'm going to subtract x from both sides, and I get x is equal to negative 7. So that's one solution. negative 7 right here. Okay, I'll put that in red right here. Oops, that's not the negative version. Let's do the green for a positive version. There we go. Sorry about the red behind it. So x is going to be negative 7. Now let's go ahead and finish with this side. Now, what I'm going to do is I'm going to leave the 2x plus 5 alone, but I'm going to distribute. It's just like a negative 1 times each one of these numbers. So negative 1 times x is negative x, and negative 1 times negative 2 is positive 2. So, let's go ahead. We're going to subtract 5 from this side and subtract 5 from this side to get my numbers on one side. And I'll get 2x is equal to negative x minus 3. And then I'm going to add x on this side and at this side. And I get 3x is equal to negative 3. Now to find x, I just divide both sides by 3. And I will get x is equal to negative 1. So on that negative side, where I branched off and I wrote the negative sign in front of what was on the right-hand side of the equation, I get x is equal to negative 1. The problem with this kind of solution is, well, you actually have to check your work. So there's a third part of this problem. The third part of this problem is to check your work. So what that means is we take the value, say for negative 7, and we plug it back in. Instead of writing a 2x, we will write a 2 times negative 7 plus 5 is equal to negative 7 minus 2. So let's do the math. This is going to be negative 14 plus 5 is equal to negative 9. Well, that's just negative 9. The absolute value of is equal to negative 9. Now, we already know this isn't true. This can't be true because the absolute value of negative 9 is equal to 9. It does not equal negative 9. So this is not a true statement. So this solution, x equals negative 7, is not a good solution. So the other one we're going to check is x equals negative 1. So 2 times the absolute value, the absolute value of 2 times, and we'll check negative 1, plus 5 is equal to negative 1 minus 2. So let's check it out. So 2 times negative 1 is just negative 2 plus 5 is equal to negative 1 minus 2 is negative 3. So negative 2 plus 5 is 3. And the absolute value of 3 is, the absolute value of 3 is 3. So we're saying here 3 equals negative 3. That doesn't work either. So none of these solutions work. So we would say that this has a no solutions answer.